Hey guys, Mrs. Dan's here. So first I want to say I hope you have a great weekend, and we have a test on Monday. So I figured I'd get through some of these review questions. This video might not do the entire review. We'll see how far I can get. And then if I have time, I'll do a second video. Most of these questions, I would say, or I could even say all of these questions are on your test. They're not worded exactly the same way, but you should know how to do every single one of these questions, and then you will be well prepared for your test. So first, they're talking about a sequence. So we know sequences are a list of numbers. We have a first term, a second term, a third term, and so on. So it says a sequence has a first value. They must be talking about the first term of 10. And each term is twice the previous term. We talked about twice, giving us, it's a key word telling us that it's exponential. So we keep on multiplying by 2 each time. So twice 10 is 20, twice 20 is 40, and so on. It's asking us to write the explicit formula to the sequence. So we determined it was exponential because of this multiply by 2, which really means it's called a geometric sequence. And with geometric sequences, given on the Regents exam, is the formula a sub n equals a sub 1 times the common ratio to the n minus 1. I might as well just use this formula that's given to me on my Regents exam. So a sub n equals the first term of this sequence is 10. We determined the common ratio to be 2 because we keep on multiplying by 2, and we raise it to the n minus 1. We're done. Now, something I keep on telling you guys every single day is after you write a function, or in this case, an explicit formula, can you please check it? Can you please make sure it really works? Take out that calculator of yours, go to your y equals, and let's enter 10 times 2 to the, now remember, my calculator is older than yours. It doesn't have that little box up in the corner. So for me to raise it to the n minus 1, I need to put it in parentheses. You're going to have it just up in that little box. When I look at this table of values, I don't care what this 0 term is. I want the first term. The first term says 10. The second term says 20. The third term says 40. And that's exactly what I wrote down. So I'm confident now that my explicit formula is correct. Now I'll move on to number 2. I'm just going to talk over these announcements. Hopefully you could still hear me. Domain, remember, are your x values. Range are your y values. I like thinking about a graph when I'm doing domain and range. So you could even put it in on your calculator. If we take a look at this graph on the calculator, I enter in y equals 3 to the x power. And I'm going to do a zoom 6. I tell you I love looking at the standard view. Sometimes I zoom in by picking a different window, but this looks good enough to me. So the x values really do go on forever. Remember, it gets so close to that horizontal asymptote. If I look at this a little bit bigger, let's see. Oh, you know what we could look at? We could look at the table of values. If we look through the x's in the table of values, do you see I can scroll forever in a negative direction? There's still stuff there. And then I can scroll, of course, forever in a positive direction. So by looking at your table of values, you could see that the domain is all real numbers. And if we were to look at the graph, if I were to even sketch the graph, it's crossing here at 1, and it's an exponential growth. And this end is getting closer and closer and closer and closer to the x-axis, but never hits it. Remember, there's that horizontal asymptote. So the x values are all real numbers, or the domain are all real numbers. Another way of writing it is from negative infinity to positive infinity. The range, though, is not all real numbers. It is forever getting smaller, but never touches 0. So it's all y's that are greater than 0. Or another way of saying it is from 0 to positive infinity. We went over this one already in class. We had talked about that the person starting it, that's your starting value, there's one person starting it. And then she sends it out to 10 people, and then each of those 10 people sends it out, and each of those 10 people sends it out. So if I think about an equation I can write y equals the starting amount, and we keep on sending it out to 10 people, so we keep on multiplying it by 10 to the x power. And you can look at a table of values for this. And you can see one person starts it. After the first round, 10 people received it. After the second round, 100 people received it. After the third round, 1,000 people received it. And that's what they ask. How many emails were sent in the third round? So I would say starting value, I guess, is 1. And then after the first round, there's 10. After the second, there's 100. After the third, there's 1,000. This is like my work. Even this equation is my work because I could plug in a 3 here to get 1,000, but the answer is 1,000. Of course, if it's an open, a short response question like this, you do have to show some sort of work on your test. It asks to write a function. Oh, I did it already. It does say in the nth round, so I'm just going to be careful when I write this function down here. I'm going to write it in function notation, so I'll use f of n. I really don't need that 1 in front. I'm allowed to keep it if I want, but I can just write it like this. This is mathematically equivalent to what I just wrote above. This is a sequence. Sometimes they give us our sequences as pictures. What I want you to do, it's not necessary, but what I want you to write down how many blocks are in this first picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now you're saying a sub 1 is 10. And then write down how many blocks are in the next picture. That would be 20. How many blocks are in the next? Oh, not 30, there's 40. And 10, 20, 30, 40, 50, 60, 70, 80. I take a look at my numbers and I try and find a pattern. It's definitely exponential because I'm not adding on the same number. I am multiplying by 2 each time, which means my exponential base or my common ratio is a 2. So how many cubes are in the next diagram of the sequence? I would just multiply by 2 to get 160. What is the pattern in a sequence? Multiply by 2. And now we have to write an explicit formula. So since this is a geometric sequence, we use the formula given on our Regents exam. A sub n equals a sub 1 times r to the n minus 1. This formula will be given to you on your test even. It doesn't have to be memorized. If I use it though, I can easily write the explicit formula. The first term is 10. The common ratio is 2, and to the n minus 1. Let's be certain that it fits the sequence that I wrote. So is 10 times 2 to the n minus 1 really equal to those number of blocks? Take a look at your table. Remember, the first term is when x is 1. So my first term has 10, my second term has 20, my third term has 40, my fourth term has 80. It's definitely matching what the sequence is on my paper. So I'm confident that I have the right explicit formula, and I can move on. How many cubes are in the 10th term? Remember, what's nice about explicit formulas is you plug in a 10 in place of your n. So the 10th term can be expressed as a sub 10. And to find it, I do 10 times 2 to the 10 minus 1. So I'm really trying to figure out what is 10 times 2 to the 9th power. Really, I don't have to calculate this. I already have it entered in on my calculator. So if I go to the 10th term, I see that it's equal to 5,120. If I were to calculate this on my home screen, 10 times 2 to the 9th power, because remember it was 10 minus 1, I do get that 5,220. But really, you could just look at your table and look at when x is 10, because that's the 10th term. Your calculator did the calculations for you. Find the approximate value of the 19th term of this sequence. So I guess what you can do is take out your calculator and just keep on following this pattern. I think we should find out what the pattern is first. Is it a geometric sequence? Are they multiplying by something? Remember, if you have a hard time figuring that out, I'm going to show you a tip on your calculator that we talked about in class. You could do the second term divided by the first term. And it says 1.1. So if this is geometric, it means I multiplied by 1.1. If it's geometric, it means this will do the same exact thing. So let's test that. Is 0.77 times 1.1 equal to 0.847? Oh, it is. So it definitely is geometric. I found my common ratio to be 1.1. So instead of constantly multiplying by 1.1 on my calculator, I mean, I could keep on doing times 1.1. That's the next one, times 1.1 times 1.1. You know what? That's kind of a waste of my time. It's so easy to write the explicit formula. A sub n equals the first term times the common ratio to the n minus 1 power. And I want the 19th term, so I'm going to plug a 19 in for that n. I could just go to my y equals button and enter it in here. 0.7 times 1.1 to the n minus 1, and go look at your table. And move down. Well, let's just double check that our formula is right. We have the 0.7 as the first term, 0.77, 0.847. I'm pretty confident, so I'm going to go to my 19th term. The 19th term is 3.8919. It does say approximately, so I'm okay that I don't see the exact answer here, but I do see a 3.89. Number 6, The table below shows the average weekly balance in a savings computation, an account where interest is compounded annually. We talked about compound interest being exponential. Annually means yearly. No money is deposited or withdrawn after the initial amount. Right here is your initial amount. It is when x equals 0. Therefore, this is the y-intercept. They're giving me the y-intercept, so when I write my equation, if I were to write it, I'm not going to do an n minus 1. Which type of function best models the given data? So they're not even asking me to write it. They're asking me which one. Well, I already said it's exponential, so it's not choice 1 or 2. And you can see that the money is growing as the x's get larger, therefore it's exponential growth. So I know they didn't ask us to write the exponential function for it, but I want to talk about how you would. You can see on my calculator that I was deciding to try and figure out what that growth factor was. I did the second term divided by the first term to get 1.48 da 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 da, and then I did the third term divided by the second term to also get 1.48 and other stuff. So I feel confident to say that the growth factor is about 1.48. We already said that this 380 was the initial amount. So I can write my function, I'll call it, I don't know, f of x, I guess, equals 380 times 1.48 to the x. This one doesn't have an x minus 1 because I know the 0 term. You can verify whether you need an x minus 1 or not by using your calculator, going to your y equals, and entering what you think the function is. So does y equal 380 times 1.48 to the x? Take a look at your table. Let's go up to where x is 0. And at 0, it says 380. At 1, it's 562.4. At 2, it's 832. And I see that the change is off a bit. I hope you're realizing that the change is off a bit because I did round this a bit, right? I used 1.48 when what we saw on my calculator was a bunch of other stuff after it. So this is close enough to what's happening in the table. I just wanted to go through that in case there's a question on your test where a real life situation occurs and you have to write your function. What is the domain and range of each? I love that the graph is here. When we have a typed graph, we are assuming that there's arrows at the ends here. So we would say that the domain is all real numbers, while the range isn't. The range never is. Right here is my horizontal asymptote, and that's at when y is 2, so my range will be all y's greater than 2. Again, the domain of this next one is all real numbers, but the range is not. My horizontal asymptote is now down here, so it's all y's greater than 1, 2, 3, 4, negative 4. Another multiple choice. Since January 1980, whenever we see like since, remember that's like when x equals 0, the population of the city has grown according to this model. X is the number of years since 1980. Which statement about this mathematical model is true? Before you even go look at the choices, I know this number is my initial amount. It's the population in the year 1980. I know that this number is my growth factor. That number came from 100% plus some other kind of percent. Let's move this decimal 2 places to the right, and I get 102.2%, which means it came from 100% plus 2.2%. So now I'm going to look at my choices. This does represent the population, but 22% was not added on. 0.22% was not added on. It's this 2.2% that was added on. It's choice 3. Be careful of your decimal point location, obviously. Write the first 4 terms of the geometric sequence. First 4 terms. First 4. First term, second term, third term, fourth term. Set yourself up for success. Don't write the 0 term. They're not asking for it. First 4 terms. And look at this. They're telling me my first term. A sub 1 stands for first term. The first term is 40. What is happening? The common ratio is 1/4. It means I keep on multiplying by 1/4. Just use your calculator even if you can't mentally do it, or if you don't want to mentally do it. What is 40 times 1/4? I'm hoping you already know it. I'm going to do a 0.25, and we get 10. What's 10 times 1/4? I don't feel like continuously opening up my calculator. I know 10 times 1/4 is 10/4. And then 10/4 times 1/4 is 10/16. Leaving it as fractions. It's really so easy for me to do it fraction-wise without pulling out my calculator. Again, if you wanted to do your calculator right here, we do times 1/4, which is really like divide by 4, and I get 2.5. And then again, times by 1/4, I get 0.625, and that's what my fractions are equivalent to. So decimal form is okay, fraction form is fine. Number 10, under certain conditions, a type of bacteria doubles. Oh, doubles, exponential. The base is 2, and it doubles every 10 minutes. Write a function rule to represent the situation. So, I don't know, f of x, I'll call it. It doubles every 10 minutes. I guess my x is representing the number of 10 minutes, and my base of 2 is representing something doubling. They didn't tell me my initial amount. When I read it like this, it's kind of like I'm assuming that there's 1 bacteria to begin with. But to be honest with you, this next question, they're asking me how many times greater the amount of bacteria is after 1 hour than when the hour started. So it really wouldn't matter how many you started with. If you're having a hard time understanding how many times greater, make a list for yourself. Let's make up a number. Let's say, oh, we'll start with 1 bacteria. And after 10 minutes, it doubles, therefore it's 2. And then after 20 minutes, it doubles, so it's 4. After 40 minutes, 10, 20, 30, 40, 50, 60. I'm going to 60 minutes because 60 minutes is an hour. It's doubling each time, so this is 8, 16, 32, and 64. The question is, how many times greater is the amount of bacteria after 1 hour? So there's 64 after 1 hour. Then when the hour started, at the start there was 1. How many times greater is 64 than 1? Oh, it's 64 times greater. And like I said, really no matter how much bacteria you started with, after an hour, it's always 60 times 4 greater. Number 11, a used car was purchased in July of 2000 for this much money. Oh, this is the starting amount. And it depreciates, which means it's losing 13%. 100%, take away 13% is 87%, as a decimal is 0.87. Write a formula to the value of the car to find the value. Write a formula to find the value of the car for any year. F of x equals the starting amount times the growth factor to the x power. This one's an x, not an x minus 1, because this starting year is before it started depreciating. It's at year 0. What is the value of the car to the nearest $100 in July of 2003? So if July of 2000 was when x equals 0, then 2001 is when x is 1, 2002 x is 2, and 2003 x is 3. So we want 2003, so f of 3 equals 11,900 times 0.87 to the third power. I'm just going to type it in my calculator. I might as well use my home screen because they're not asking me any other questions. So I don't need to go to the y equals. You could, though. Now we're talking about money. Oh, and it does say to the nearest $100. Ooh. So at first I would have written down 7,836.19. That's to the nearest cent, though. They're asking us to the nearest $100. Here's the hundredths place. So they want 7,800. Got to make sure you round to the place that the question is asking. Use the graph below to answer the questions that follow. You have to know how to do average rate of change. I see this question on Regents exams probably every single year. Average rate of change. Rate of change is like slope. You want to think about y2 minus y1 over x2 minus x1. They have to tell me from when to when am I finding a rate of change, because with exponential functions, the rate of change is always changing. So they're asking me to find it right here. When we do the slope formula, we need 2 points. So one of your points has an x value of -2, while the other point has an x value of 0. Go look at your graph. When the x is -2, the y is 4. When the x is 0, the y is 1. Here's the 2 points that we're using in our slope formula. So 4 minus 1 over -2 minus 0, 3 over -2, which really means it's -3 halves, or -1.5, or -1.5. Any of those ways are acceptable. Write the explicit function. So f of x equals the initial amount. Now I'm going to pick what's on the y-axis. I'm going to pick when x is 0. I have to see how much this is decaying. Interesting. So this y value is 4. This y value is 2. This y value is 1. I'm going to make a table of values. You can see over here that it looks like it's getting divided by 2. Remember, though, we like it as multiplying, so we're actually multiplying by a half, which means our growth factor, or the R, is 1/2 to the x value. It's not the x minus 1 because I used the y-intercept. Again, if you're unsure if it's an x minus 1 or not, go to your y equals, enter in what we just wrote. I'm going to use a 0.5. My calculator doesn't really do fractions because it's not updated. And take a look at your table. Make sure you're getting the points that we just wrote down in this table. So at -2, I have 4. At -1, it's 2. At 0, it's 1. Yep, I did a good job. So I'm done. This is my answer. Here's a classic riddle. There is a question similar to this on your test because we're going to be comparing a linear function to an exponential function. So Mr. Smith has an apple orchard. He hires his daughter Lucy to pick apples and offers her 2 payment options. Option 1, $1.50 per bushel of apples picked. So she'd get $1.50 for one, and then another $1.50, so $3 for 2, and so on. It keeps on going up by $1.50 per bushel. That makes this linear. It makes me already want to write y equals $1.50 x. If she picks 1 bushel, she gets $1.50. If she picks 2 bushels, she gets $3, and so on. Option B is that you get 1 cent for picking 1 bushel. I'm going to write that as 0.01. And then 3 cents for 2 bushels, and 9 cents for 3 bushels, and so on. So what's happening? They actually tell you the money is tripling. If I keep on multiplying by 3 each time is how I'm getting my payment. So if it's multiplying by 3 each time, or if it's tripling each time, those are some keys, words that tell us it's exponential. So part A, write an explicit function to model option A. So I'm going to call it A of x, and it's that 150 times x. And then for option B, I'll call B of x. Now this one I'm going to write as a sequence notation, because this is my first bushel and my second bushel and my third bushel. So it's reminding me of a sequence. I might as well use that formula that the Regents exam gives me, where I use my first term, I multiply it by the common ratio, and raise it to the x minus 1. And again, test these things out. I'm going to put them both in here. So for my y1, I'll use option A. And for y2, I'll use option B. I'll look at my table to make sure I wrote everything right. So option A, if I pick 1 bushel, I get $1.50. 2 bushels brings it up to 3. 3 bushels, $4.50. Yep, that's what the wording says. And for option B, I get 1 cent, 3 cent, 9 cent. Good. So I wrote my equations just right. So let's look at the rest. If Lucy picks 6 bushels of apples, which option should she choose? Let's just go back to that table. And we're going to go look at 6. At 6 bushels, option A gives me $9. Option B gives me $2.43. She should pick option A. Now, on your Regents exam, or on your test on Monday, if you just look at your calculator and then write option A, you do not get full credit. You're in a part of the test where you must show your work. So you need to copy down your table. So what we can do is make some kind of table indicates everything. So I'm going to write number of bushels here. I'll call this A of X, and that's clear since that's what I called it here in part A. And I'll call this one B of X. And remember, A of X is like the money earned, and B of X also. So picking 1 bushel, 2. So if I copy down up to 6, I actually have enough information. Oops, sorry, that's 1 cent. $0.81 and $2.43. So she should pick option A because $9 is greater than $2.43. How many apples need to be picked with each option to earn $9? So I already have the answer for option A. She needs to pick 6 bushels to earn $9 with option A. Actually, I'm going to move these words because I'm going to be extending my table. And how much does she need to pick with option B to get to $9? So So next is $7.29. So I didn't get there yet. And then next is $21.87. And I made it. She needs to pick 8 bushels. And she'd actually earn more than $9. But 7 bushels isn't enough because 7 bushels, it's only $7.29. So let's graph both functions to determine how many bushels of apples Lucy needs to pick to make option B better than option A. So without even graphing, I can see right here that option B is better than option A because $21.87 is way higher than $12. And now here is a graph. You can see along my x-axis I put the number of bushels and I spaced it out nicely. And my earnings was along my y-axis. And my scale is by 2 each time, and I carefully graphed it. So you can just use the points from your table to plot them so that maybe it's easier to draw your line. Because remember, counting slope, if it's a rise of 1.5 over 1, that might be tricky to do on this graph with how the scale is. So why don't you just plot some of the points? And then with option B, that's what I did. I plotted the points. Now those ones at 1 cent and 3 cent and 9 cent, I mean, that was tricky to plot. So I really was just very careful with the steepness of my line. It's not horizontal, it's gradually going up, but holy cow, does it take off so fast, right around like 7, 8, it is beating that linear function so quickly. So you can see option 8 is where definitely, not option 8, 8 bushels is where option B is way better than option A. And if you're going to pick more than 8 bushels, definitely go for option B. I think we're getting there, right? So it says here to use the table above to answer the following questions. Write the function rule for the table above. So we have to first decide what kind of function is it. It's definitely increasing. When things are increasing, they could be linear or they could be exponential. Can you tell if it's growing really fast or not? Like something you can look at is there a common difference? Is there a number that we add on to get from one to the next to the next? If I was adding 24 plus 12 would give me 36. And then if it truly is adding the same number again, it means I would have to add 12 again. And that gives me a 48, not a 54. So I'm not adding the same number again, which means it's not linear. So I guess it's exponential. What number am I multiplying by? Remember, you could go in reverse. You can do 36 divided by 24, and it's saying 1.5. Does 1.5 really work? What's 36 times 1.5? We get 54, and that's what it says. What's 54 times 1.5? We get 81. We found it, didn't we? The common ratio, or the number we're multiplying by, is at 1.5. It is exponential. It's exponential. They didn't give me the zero term. They're telling me that the first thing is 24. So you can use that formula they give you on your Regents exam. A sub n equals the first term times the common ratio to the n minus 1. Oops, it does say a function rule. I do see an f of x up there. I love it when I kind of make mistakes and have to change something. I'm not allowed to call it a sub n. I have to call it f of x because that's what it says right here. And I can't use an n in my exponent. I have to use x. So you notice I go back and I look and I make sure. So this is what you need to do when you're taking your test. You can check and make sure this is the correct equation. Is it generating what that table says? So at 1, I have 24. At 2, I have 36. At 3, I have 54. I'm confident. Take a look at this table on the screen now. Isn't the y-intercept at 16? Which means if I wanted to write an equation using the y-intercept, which we like to call the initial value, which means my exponent is just an x, not a minus 1, I could say f of x equals 16 times 1.5 to the x, and these two equations are mathematically equivalent. Don't believe me? Let's go look on our table. Sometimes they do ask on a Regents exam if the following functions are mathematically equivalent. So you should be able to recognize when things are or aren't. So if I enter this into my calculator, and take a look at the table of values, do you see it's identical? Identical. They're mathematically equivalent. It generates the same table. So this is how you could even go from one form of the equation to the other. Anyway, it's asking what the average rate of change is over the interval from 0 to 4. Remember, they're telling me to use 2 points. One point has an x value of 0. The other point has an x value of 4. Go look at your table. They don't have the 0. Good thing I went and did this before. The x value, when x is 0, the y value is 16. And when x is 4, the y value is an 81. Let's do y2 minus y1 over x2 minus x1. (81 minus 16 over 4 minus 0). And 65 divided by 4. 16.25. So that really isn't all you should do, but hopefully this was helpful. I would go do that second review. I sent the answers out and remind. I would look through my entire workbook. You should have correct answers to all of our homework assignments because I do print out my answers and give them to you. And if I don't print them out, we display them on the board and it's your job to fix things. So I really do wish you good luck in doing this. I feel like it's a pretty fair test. It's everything that we've done. And good luck. See you Monday. Bye.